modularity. My name is Zoran Ševarec, and I'm assistant professor at the Faculty of Organizational Science at the University of Belgrade in Serbia. And together with me are Jaroslav Tulak. He's from a NetBeans team from Prague, working in Oracle, and Anton Apple, he's from company Apple IT Consulting. Today we are going to talk about various experiences while developing modular applications, and I guess all of you are aware of them, and during your work you got them, but it's a good way to summarize them in some way and to show you how you can use some interesting tools so you can discover patterns and dependencies that you might not be aware of during the development of your application.
So maybe we can ask who of you is using using modularity in some way? Okay. OSGI. NetBeans module system. What else do we have? Like Spring.
Spring.
Okay. Cool. Thank you.
So the next year sessions should be focused on Spring, right? So those are the three mentioned are to few popular modular systems, and our approach that we look at patterns that we are familiar with in UML design, class design, and we map them onto the modules, just onto the higher level. Making the game is same, just at the higher levels of abstraction. So what the definition of a design pattern is: a general reusable solution to commonly occurring problem in software design, which simply means that some mistakes, many of us are making the same mistakes, and we should be aware of them and avoid them. And some good solutions can be also applied to different contexts. And that's not anti-patternism exactly. Anti-pattern is a pattern that may be commonly used, but it is ineffective and counterproductive in practice. And is some kind of a bad practice that people tend to use because at some point of time it is easier to just make something work and deliver the application. So, what are the commonly occurring problems when creating modular applications? Well, we always want to make our design reusable, so we don't have to create the same things again and again. We want to make it flexible, so when the client requests a change, we can easily apply that change without changing too many code. And we want to have good dependency management between modules, so we are taking care that application design and overall structure is maintainable during the application lifetime. So here is the key to the modularity, which was defined by Tony 2 years ago, and up to date still stands. So I will kindly ask Tony to explain to us his 6-5 principles of modularity.
Well, thank you very much. Well, I just scribbled down these 5 principles of modularity, which are actually 6. And you will have to comment and explain why it's only 5.
Because one of them is inherently present in another. So it's only 5.
So maximize reuse. I mean, they're quite obvious. So we are supposed to maximize reuse, and pattern is nice if it helps you to maximize reuse. Minimizing coupling is another thing. There are a lot of deep coupling techniques, like using service provider interfaces, service infrastructures. Dealing with change, that is also very important. So there are a couple of patterns, especially in the APIs that help you to develop your API, to increase your API, to improve your API, and change it without breaking compatibility. So dealing with change is very important for modularity, because in module systems you have like these contracts between the individual modules. Ease maintenance, that is probably inherently present in deal with change. Yeah. Ease extensibility. Patterns that help you, like creating plugins. And save resources. Those are patterns that deal with, for example, lazy loading, you could think, and only instantiating stuff that you really need. So those are the patterns that, those are the principles that should be applied to assess if a pattern is good or not.
So if you're wondering sometimes, should I do this or not, you can evaluate according to these principles and see what are the gains and what are the losses. Sometimes you might gain for reusability, but that may actually lead to the code that is easy to maintain in a long term for some reasons. So this is the game. Actually, there is no perfect modular design because the requirements are changing, and during the application lifetime, you'll be adding new features and changing existing, and that's the design of application which may be solid in the beginning, may become very messy over time, and it's very hard and sometimes unpredictable in which way it may go.
Yeah, that's true. But I saw a study that 75 requests for changing your code base usually comes with feature requests, something add new functionality, and only the 25% are restructure the code, switch to different technology. So for example, for us, rewrite JavaFX would be the technical change, but that's not as common. Very often.
Yes, that was the point. You're not changing the structure of the application just because you want to change it because it is nicer, and that's the way it should be done. It's because you need to add new features, you need to change the existing one.
So when you are about to estimate the future evolution of your application, bet on the new feature requests.
So our idea, one of the things that we did is to use some graph mining techniques to discover dependencies and issues in large modular application, and it is a pretty simple approach. We extract the module dependencies. We are using this platform application, and then load those dependencies into some graph processing application. We have used Gephi, which is also in this platform application, and then play with the algorithms that are present in Gephi to discover, to show you what you should be looking for. So I will show you how it's done. So this is doing some scaling too. It's gone. So let's open, for start, one simple application. It's called Neural Studio. It's a platform application for creating neural networks. And since I've been working on this application, I know what its current issues. So just open it. Where is it? I can't see it. Shut down this for a moment. So this is the graph dependency graph from our application. And what we can do now is to use these algorithms and say show the nodes by using degree, and we say that let's use the size. Say minimum size is 5 and maximum 30, and we can now identify the modules that have how do you center distance? That there are lots of dependencies using layout algorithms, and let's turn on module names so we can see what's going on. We can even make them bigger, right? Like this. So this is the project suite. It's a model suite, so all other modules depend on it. So it's okay. This is the biggest one red. But the other one that are red are potential issues. They might not be, but they have a lot of dependencies. And when they have a lot of dependencies, those are the ones that you should look at. So I know what's wrong with this design, and it's also clearly shown on this graph. Because when we were creating this application, it was a swing application, and we moved everything from an existing application to the main module. And some of that was in the next iteration or development extracted into the IDE module. So these are two modules that most other modules depend on. So if we do this, we can see what modules depend on module name. And you can see that those are almost all modules in application.
Well, I guess the more modules use, the more other modules use certain module, the more careful you should be when you are making a change there. Yes. You can influence a lot of other stuff.
Yeah. Two things that might be a principle that you very simple that you should always ask yourself is if I change something in this module, what else do I have to change? Do I have to change a lot of things? And if I want to deliver this module into some other application, what other modules do I have to deliver? That's how I figured out that this design is pretty bad when I realized that when I'm delivering, for example, support for image recognition, I also have to deliver support for stock market prediction and handwriting recognition, which is unrelated. Maybe someone don't know, because of the dependencies to the main module and the IDE module.
Yeah, I use the term how heavyweight the module is, because the outgoing dependencies of a module basically describe the environment that is necessary for that module to be used. And especially when you are trying to take certain module and bring it from one system to another, like we are doing when we are sharing functionality between NetBeans and JDeveloper or between NetBeans and Eclipse. Then basically we are interested in one module, but then we would like to, we also need to get all the dependencies. So the more heavyweight the module is, the more problematic a reuse is as well.
So what we have just loaded is the module dependency for the Wizards API from the NetBeans. Okay. So yeah.
That's more complex application.
That's more. So you see what's the issue. When you have a simple application with the 10 modules, then it's kind of obvious. And you know. But when you have this situation, then having just picture in front of you might be very useful, especially when you have a tool like Gephi. So you can say, okay, let's do a degree. So we can choose input degree and output degree. And degree is the sum of the input and output. So how many modules depend on some module, right? And what other modules depend on that module. So we can do the same thing. I like to use this color, degree ranking, and size. So we clearly get that lookup, everyone depends on the lookup here.
That's true.
But that's
It's
okay.
one of the basic APIs.
It's the infrastructure, right? It's the infrastructure. So you can always think about the modules, you know, a kind of maybe if you think about or tiled or layered architecture. So you have modules which are related to infrastructure, and then applies to the specific.
In every module system, you basically, or the framework in the module system needs to give you a chance how to register services and discover services. And that's almost necessary feature of each module system. OSGI has support for services and NetBeans as well. And actually, this is done by the lookup API. That's the reason it's so heavily used. Anything else that is right?
Yeah, that is interesting.
So you've got a Spring embedded now.
Sorry?
So you've got a Spring embedded.
Yeah. These layout algorithms, there are a variety of them. It's this one, maybe Tony can explain, but it's, you know, the biggest modules are in the center, and you see the smallest are around us. And what we can also do, use this filtering, topology filtering, right? And use degree rank, put them there. And let's say we don't want to look.
So which ones are the most prominent ones here? Utilities API, lookup, and
Here it is. See? We have filtered out all modules that have small number of dependencies and just analyze it. So what do you have to say in your defense?
Well, this shows the important APIs, basically. Yeah. So actually, all these modules are APIs. Those are not implementation modules. So it's fine that they are used a lot. And of course, if you want to deal with files, which is exactly what the project support does, it needs the dependency on data systems and file systems API. If you want to work with Java sources, then yeah, that's okay. It's using Java source API as well.
The other thing you can do is take a look more at the modules with very few number of dependencies. You know? So Tony will explain it on this. So these are. Tony will explain the possible scenarios. Can you comment on this?
So the modules with very few usages are those implementation modules.
Yeah.
This is the case.
So there are a variety of things that.
so actually, if you've got if you've got APIs turning up here, then you've probably got a problem that I refer to as ghost towns or premature modularization. That happens a lot actually. So you have a lot of guys who are eager to create nicely modularized applications, and in the end, they will only have one implementation ever in their life, and that might be a problem.
And usually, modularization should be driven by some purpose.
Yeah.
When we started, for example, the NetBeans developer sharing, then we needed to make certain modules more lightweight. Remove their dependency, separate them into two parts, so we can just take the important part and move it into different environment. And so basically the modularization should be driven by needs. It will tell you the right granularity for particular need.
So these are some anti-patterns, right? That Tony will explain it.
Yeah, that's my contribution for this year, making up good names for these things. And the first one is clandestine dealings, and that is basically when you have APIs. There are APIs, that exist, but they aren't documented. Like, for example, there are magical strings that you pass in somewhere, some system properties that you can set, but it's nowhere documented that this exists. I think Yarda had last year had one nice example that even made one guy in the audience yell at him.
Yeah, because I was too critical about OSGI. OSGI specification allows you to install a module. It has method install bundle, and it takes a string parameter which is called URL. So I was thinking, okay, I can put that file URL, I can put the HTTP URL, and yeah, that really works. But in Eclipse and in Felix, both, which are two different implementations of the OSGI API, of the OSGI container, you can also prefix the URL with reference word, form a magical string, and this means the container will use the file from a disk without copying it into some own directory. And this is, of course, not documented anywhere. It's a magical API.
So the next one is prohibition, which is a phenomenon that goes with prohibition. Like when we had, when you had the United States had prohibition. The guys who wanted to drink alcohol still found ways to drink alcohol, right? So there are lots of tricks that developers are doing to still get to call into the APIs, into the implementations that you don't want them to. Like, for example, they are using reflection, or I think you mentioned that the JRebel guys in their presentation said they commonly see people doing bytecode patching to just call into things that they shouldn't.
But on the other hand, it's clearly beyond the boundary. Those people know that they can shoot themselves into their own foot.
Yeah, it's, well, but as I guess any of you, we tend to find interesting methods in implementations and cast to the implementation if nothing prevents us from it. And I think I did that, and module systems make it more complicated to do it, but they don't really prohibit you from doing it. And I recall a lot of times when I was dealing with XML parsers and stuff like that. They've got very interesting methods, and the APIs, can you? No. I'm losing power. Okay. So let's go. Okay. So the next one, I think it's not a very, the next one is hedge marriages. And that is, while it does look like an interface, while it looks like an interface that can have several implementations, it isn't, because somebody introduced a dependency. So the whole system actually depends on the implementation, while it looks like the system only depends on the interface. And that is something that you see a lot of times in module systems, and I've also seen it in NetBeans once. Yeah, and that was when we wanted to create a different Windows system. And you can imagine, Windows system of NetBeans is very good. So it's very rarely would somebody like to create a different implementation. But there was a customer, and they wanted to have like a Windows system implementation where you have floating transparent windows over one central radar screen, basically. And so I found out about this problem. It was a known problem. Jesse had already written a bug report about this, but it's there. So somebody has, in a different module, has taken the interface and casted it into the implementation, and with this we're done, basically.
And to evaluate this according to your 6.5 principles, yeah. This is increasing coupling, and yeah. That's bad, of course.
And that's a bad thing. Yeah, we already talked about ghost towns, premature modularization. So when you do modularize your application, it can add complexity, and it's not always a good thing. And it's also something that I've seen a lot since a lot of you are using Spring. That is a very typical pattern in Spring. That there are a lot of developers who are you simply create interfaces for everything, and I've seen people creating whole object relational mappings to just copy a database or stuff like that.
Basically in NetBeans, when we are developing some APIs, usually it's feature request driven creation of APIs. Often we require at least 2 independent use cases, maybe even 3, before we try to create an API, because maintaining APIs is slightly costly.
Exactly.
So if you have just 2 copies of the code somewhere, then that's relatively okay. That's simpler. But on the other hand, I also know that if you want to expand, if you want to stimulate evolution, basically, then it's good to create new API. For example, in NetBeans, I created the command line API, so people can really pass the parameters that are passed into the NetBeans based running application. And different modules can participate on parsing the command line. They can cooperate with each other. And at that time, we had just one module using that API. So it goes against the principle to introduce the API. But I think it went really well because there are many usages. People found the API useful. So if you want to increase evolution, you need to go and risk the ghost town.
It's an interesting story also that when I found out that it's actually obvious that it's a lot of work to maintain an API. So when you open up an API, you have to maintain it, and that's why developers usually don't want to create APIs because they will be responsible for that. So you have to fight. You do a lot of fighting. Like I remember that with the XML multi-view API, there were a lot of people using it outside of NetBeans, and they wanted to use it, but it was very. I think it's still not an API, right? Officially.
It's
multi-view.
Those guys who created the API just are really afraid of stabilizing it. But the good thing is that they don't touch it. That means it's stable enough, and the usages of that API don't get broken over time. That's at least a example.
It's a don't touch it if it works better, right?
So the next one we've got here is eagerbeavers, and eagerbeavers is an anti-pattern in that you can see, for example, in OSGI or in NetBeans module system. There are lifecycle methods, like in OSGI activators. In NetBeans module system, it's called module install. It's basically the same thing.
Huge mistake.
Yeah, and those are classes that are called when the module is loaded. So people use them to set up services or to connect to databases, do stuff, register things. And that's an old pattern. Basically, OSGI has found better ways of doing service registration than doing it declarative way. And NetBeans module system did that as well. But if you do that a lot, the objects will be created very early. And they will maybe never be used.
There is a price to that. And actually, I call it the syndrome of most important functionality. Whoever developer works on some module, like support for PHP or support for UML inside of NetBeans, thinks, oh, this is something everyone has to use. So let's initialize it at the beginning. But most of the users don't use PHP. So they start NetBeans, but they pay the price of the initialization. If it's done, well,
yeah. So the next one is bigamy and promiscuity, and I think at least that's what I jotted down as notes. I don't know if it really fits the name, but It is incompatibilities between different implementations. So that is something that you sometimes see. You've got an API, but the API defines interfaces. It does not necessarily define the behavior. And different implementations might behave differently. So, for example, we had that once in Lookup, which is a very important API. And the thing was that you had to, in some implementations, call a certain method first before listeners would be registered correctly and listeners would be fired. The events would be fired, but only for certain implementations. And so that is clearly not in the API in terms of libraries. You cannot define the order of calls, but it was causing trouble.
I know. So the only way how you can deal or fight against that is to associate your API also with TCK, test compatibility kit. So that's a basically generic set of tests which everyone who is providing implementation can run against their implementation to verify it's compliant enough. And actually we have TCK for Lookup, but this test was not there. Now it is there. I guess the issue is fixed. We have also TCK for file systems. I mean, we have a pluggable file system API, and we have a file system for accessing remote computers over SSH, local disk, zip files, and we need to ensure that it behaves correctly. So for that we have TCKs.
Okay, then we get one other one, and that's the small world phenomenon. And that is probably something that a lot of you have seen, and a lot of companies are fighting against. Like for example, in Munich, where I'm coming from, BMW has this blueprint where they limit the libraries that can be used inside the application. The small world phenomenon means everybody knows everybody over 6 hops, basically. So developers, especially in their younger years, tend to simply reuse work done by others, and maximizing reuse is a good thing. But if even for small functions, you grab a new library that does what you want, and it's only a small thing, you might end up with a lot of dependencies that you need to maintain, and there are
basically you manage to maximize reuse.
Yeah.
So you are reusing, but you completely prevented reuse of your module. Because nobody can use you. You have really heavyweight dependencies, and reusing you is really hard. Actually,
increasing the weight, right?
Yes.
Yeah.
We were recently dealing with some web application, and it really contained every possible library. So each developer had their own favorite JSON parser, so that's real. And well, it affects the final application. Instead of the server to start in 1 megabyte, it needs 1 gigabyte.
So I remember from my earlier days as a developer that I was doing so much pruning basically and finding actually libraries. I mean, it even happens that there are no actual dependencies. It's just like you take one library and it ships with all these other dependencies, with all these other jar files. So what you do is, for convenience, you just include also all these other jar files, if you need them or not. So that is basically what is the small world or LinkedIn phenomenon.
And I can continue with one example about modularization that we had in NetBeans. So NetBeans the NetBeans design started somewhere in 1997, and well, it was not bad design. What we wanted to achieve is to have one module with all the APIs for accessing the IDE functionality. Then another module with implementation of those APIs. And then many modules using the API and communicating through the API, providing Java support, HTML support, and stuff like that. So we had one huge module with all the APIs. And we find out that that's probably not good, because not all the APIs are needed as frequently. Not all the API, not everyone needs ability. Well, when there is an object that you can copy or delete, should it also have a method can compile, can debug? That was our original design, and that was completely wrong, because the fact that you can copy something does not mean it should also even know and care about compilation and debugging. So what we did, we slowly realized that having one module with APIs is wrong, that we need to split it to many modules. And yeah, in the year 2005, we really did it. And we started with compile time separation. So we still produced the single jar file, but we tried to clean up the dependencies between those 14 parts. And it wasn't easy at all. The original vision was that, for example, Nodes API should not depend on Windows. But the reality is completely different. And that happens for many applications that you start with a clean design, separation and dependencies between packages. But honestly, you are prevented by compiler not to make dependency calls between those parts. For sure, you will do it, or one of your developers will do it. I guess this is something that happened to AND. The original AND design was really nicely separated package by package with directed dependencies between packages. But it was just a logical design. And now when you look at interdependencies between AND classes, it's a mess. So we had the compile time dependency, and that allowed us to prevent future regressions. In 2007, we really separated the 14 modules into individual parts, into individual jar files. But the problem was that immediately we started to have a performance regression, because modularity is nice, but there is some price to pay for opening and reading classes for 14 files instead of from a one file, especially when all of these were on a class file. Yeah, so we needed to do something with that, and we created some caches that returned the performance, the startup time back under control. Now we are probably faster than at the time. Yeah. And actually, having the fine granularity and having modularity is a nice way how you can eliminate certain modules. I like to say that APIs are like stars. So basically, you cannot get rid of them. As soon as you publish an API, you should it should be there. You don't know who is using it. You should keep it. But with modularity, there is a way how send a star into a black hole. How you can basically deprecate and slowly remove a certain API. So we did that. We decided that the options API is wrong and that we want to get rid of it. So we slightly arranged the dependencies between these modules, separated the options API into own module, and rewrote all our other modules not to depend on it. But we didn't know about third-party implementations, so they could still use this API. So we included the API in the NetBeans installation for those who want to use NetBeans platform, but it was disabled. Still, it allowed smooth migration path. Basically, in case somebody depended on the options API, they could still use it, and it got enabled. But it printed a warning into a log file saying, okay, don't use this, don't use this. Basically, modular systems should help you even with deprecating APIs and moving forward, cleaning your APIs, and easing maintenance. I should probably mention that this story is also part of a book that I just finished. Can you switch to the browsers around, please? Yeah. So this is cover of my 2 years old book, but I just finished new one. You have a browser? Okay. Yeah, so in case you visit paradoxes.apidesign.org, you will be able to see the 20 API paradoxes book. Okay. That's probably all from my side.
Ah, that's the end.
Yeah.
Do you have any questions? Yes.
For module design, how much do you work on design up front, or do you let it more emerge over time?
Well, I prefer being ready for changes. Of course, having some design or one of the paradoxes talks about APIs, saying that most of the time when you design an API, you are not a developer, you are a sustainer. Because as soon as you publish first version of an API, your creativity is limited. You need to keep backward compatibility. You cannot remove methods, you cannot refactor classes. So doing the first initial design right is beneficial. But on the other hand, you can never be completely right. You need to be ready that you will need additional changes. So the important thing is try as hard to do the first version correctly, and then also do it in a way that you will be able to improve the design over time.
Any more? So that's it, folks. Thank you for coming. And